Hello guys and welcome back to this one. Today we are going to be looking at the final method in solving the test for cyclicity problem that we started a minute ago, right? And today we are going to be looking at the concept that I would like to first show the code and then just speak about the code. Then I speak about it graphically so we get to graph. And I'm so happy about this graphical illustration because it kind of showed two like edge cases or an edge case that makes sense, right? Now we talk about the Floyd slow fast pointer. So we have two pointers pointing to the head of a singly linked list, and then we have a while loop calling fast and fast dot next. Now the reason why we are calling fast and fast dot next is something I wrote here. So we do while fast and fast.next because that is the only point where we are sure that fast.next.next is either a node or none. So if fast.next was a node or none, right, we are going to well, if fast.next itself, right, was a none, that means we are going to have to go and say none.next because that is going to defeat the whole purpose of what we are trying to do because none has no next, it's not a node, right? So while we do that, we go through the fast.next.next and we move fast, very fast. That's what we call it fast. That's two paces at a time, and slow, a pace at a time. And if slow is equals to fast, then we break our loop. Now, if our loop is to fail for some other reason, then we return none because we know that the only reason our list will fail is if our list is not a singly linked cyclic list, right? So that's why we drop there, and then we call slow to head, and then we then go again on the while loop, and we say if slow is not fast. So as we now start moving fast forward a pace at a time, while slow forward at a pace at a time, and this is all going to come together in a short while. Now, so here we have our slow fast pointer. But before this example, I want us to look at this one, right? Where we have these two pointing to this. So let us play out the code right here and right now. Now the code says we take two guys pointing to the head. One is moving faster than the other one, and the other one is moving slowly. Now fast moves two paces at a time, slow moves a pace at a time. Fast moves two paces again, and slow moves a pace. And now they found each other. Now, when they find each other, what do? We look at the code. It says we should break out. And once we break out, what do we do next? Now, it's not an else. We've broken out of the while loop in a natural state. And now it says show head. Slow, I say show head as well. Slow equals to head. So what does that mean? It means that we take our slow again and we point it to the head, right? And then we now move them one pace at a time till they find each other again. You see it here up until slow is if while slow is not equal to fast, meaning that the only other situation or the situation why this when this while loop would stop would be when slow equals fast or it becomes fast, right? So fast moves a pace, slow moves a pace. Fast again moves a pace, and slow moves a pace, and they are here. Now, one will say, "Oh, but they found each other before. Why didn't we just call that spot where they found each other before the cyclic start?" Now, that's literally the intro to this example, an example that varies, right? Where we could have a different scenario like this. And let us now look at it and see, oh, does this actually also align with in this example? Are we supposed to, are they also going to meet at one on the first try? So we take fast twice and oh god, I want to break my stuff. So frame. Now move with once, move this guy twice, move this guy once, move this guy again twice. Now One will say they found themselves again, but remember our code. Our code says move fast twice, move next once, then call, then check if they are this thing. So we've moved fast twice, we've not moved slow once, so we can't check. So we move slow once. Now we move fast twice again, then move slow once, and we are here. So we see that now we found they found each other in somewhere that is not the cyclic start, and then we come here and say, oh, slow, come back to this guy. Now fast, now move at a pace at a time. Fast moves at a pace at a time, slow moves at a pace at a time. Fast does that again, and boom, they meet. This while loop stops and we return slow, which is the cyclic start of the singly linked cyclic list. And we can look at complexity immediately. It says this solution takes an O of n because we visit every node at least once, and then the space complexity is O of 1 because now we are not using any, increasing variables. Unlike the other stuffs we did where, we held values in a set or in a list. So that's it basically for the Floyd slow fast pointer method. Hope you enjoyed this one. Muchas gracias. Auf Wiedersehen. Tschüss.